So today we're diving into something pretty cool, a sort of hidden light show happening way up in our atmosphere.
Yeah, it's called Airglow. We've got some notes here describing it.
Right. And the idea is to get a handle on this faint green light, what it is, how it's, not like the auroras.
And where this amazing picture we're looking at was actually taken.
Okay, so let's start with the visual. It's this faint green haze almost, captured above the Silla Observatory.
Exactly, Silla in Chile, the Atacama Desert. It gives this soft, beautiful glow to the whole night sky in the image.
But you mentioned it's hidden, so I can't just go outside tonight and see this.
Well, probably not, no. It's generally way too faint for our eyes.
Ah, okay.
That's why you need places like the Atacama, super remote, incredibly dark. The European Southern Observatory runs Silla, and they work hard to minimize light pollution.
Makes sense. You need sensitive cameras and darkness.
Precisely, to capture that faintness.
So let's clear this up then. It's green sometimes, but it's not the aurora like the northern or southern lights.
Correct. That's a really key difference. Airglow is, well, it's constant. It's always happening, more or less.
Always.
Yeah, pretty much. It's caused by ultraviolet light from the sun. The energetic stuff we can't see heating atoms and molecules high up.
Okay.
It bumps them into a higher energy state,
Yeah.
right? And when they naturally drop back down to normal, poof, they release a tiny bit of light.
And the green color.
That often comes from oxygen atoms, specifically. But you can get reds or yellows, too, from other atoms or molecules like sodium. It actually tells scientists about the upper atmosphere.
Huh. Interesting. So it's like a steady, low hum of light, always there.
That's a great way to put it. Now, auroras, they're totally different.
Right. Those are the big, dramatic curtains of light.
Exactly. They're caused by charged particles, from the sun, the solar wind getting funneled by Earth's magnetic field and slamming into the atmosphere near the poles.
And they're much brighter.
Oh, much, much brighter, but also brief, unpredictable. Auroras are like a sudden fireworks show. Airglow is the gentle background glow.
Okay, got it. Constant hum versus fireworks. Now, this specific image from Silla, it's an equirectangular projection. What's that mean visually?
Think about a map of the whole world laid flat. You know how Greenland looks huge and Antarctica gets stretched across the bottom?
Yeah.
It's kind of like that. It lets you see the entire sky, 360 degrees, in one flat image, but the stuff at the top and bottom, or the edges of the sky, get stretched out.
Ah, okay. So it distorts things a bit.
Yeah.
And the source mentions trying to spot the telescopes in this view, like a little game.
Yeah, it points out ESO's 3.6-meter telescope down at the bottom. The description says it looks like it's puffing the Milky Way like smoke. Kind of poetic.
Yeah. Where else should we look?
Well, there's the Swiss 1.2-meter telescope, the Leonhard Euler telescope. That's apparently easier to find. Top left in the image.
Okay, top left. And there's one more.
The New Technology Telescope, the NTT. The source says it's sort of hiding at the top. Might take a closer look to find that one.
Fun. And can you actually, visit these telescopes?
You can. ESO offers tours at Silla, but they're during the daytime.
Ah, right. So no airglow viewing then.
No, afraid not. But seeing those massive telescopes up close is still pretty amazing. Definitely worth it if you're ever down there.
Definitely. So wrapping up, the main thing to remember is this constant, really faint light airglow happening way up high all the time.
Yep, caused by sunlight energizing the atmosphere itself. Totally distinct from the more famous flashy auroras.
It's kind of mind-blowing, isn't it, that this subtle glow is always there, just beyond what we can normally see.
It really is. Makes you think, about all the other quiet, constant processes happening in nature that we just don't notice day to day.
And how technology like these sensitive cameras lets us peek behind the curtain.
Exactly. Maybe next time you're looking up at a really dark night sky, you can imagine that faint, invisible layer of light that's always glowing.